Okay, on today's video, you are watching Intro to Stoichiometry, how to do mole-to-mole type of stoichiometry. So we're going to start off by first having a balanced equation. So you can't do any of these problems unless you balance the equation first. So then you notice that you have this equation that reads propane reacts with oxygen, and when that happens, you produce carbon dioxide and water. Okay, so you usually start with your metals, but we don't have any metals now in this particular equation. So the next thing is to start with our nonmetals, which is carbon. So if you notice, there's a 3 next to this carbon, and that tells me that I could say that there's 3 carbons here. And if I look on this side, notice there's only 1. And when I say this side, I do mean products being on the right and reactants being on the left. So looking at my products, I have that 1 carbon, but I really want it to be 3. So what I'm going to do is I'm going to place a 3, and by doing that, it's going to multiply by this 1 to make 3 carbons. So now those carbons would be balanced, and now I have to go through the rest. Remember, I always leave hydrogens and oxygens to the end. So I'm going to go ahead and take a look at the hydrogens on this side. I have 8, and on the side of the products, I have 2. So I'm just going to go ahead and write that I have 8 hydrogens on the reactants. And now how do I make those 2 hydrogens on the products into 8? So I could definitely put a 4 there and then multiply by this 2 to make it 8. So if I do put that 4 times 2 is 8, and now I have 8 hydrogens. Okay, so now the hydrogens are taken care of. The only thing we have to do is work on getting those oxygens balanced. So if I look on the side of the reactants, okay, we see that oxygen, there's a subscript of 2, so I'm going to go ahead and write 2. And for oxygen on the side of the products, well, it has it on 2 sides, so we're going to actually have to add those 2 together. So this 3, because it's already there and it's part of that formula, we're going to multiply this 3 times that 2 because it's right in front, it's a coefficient for carbon dioxide. So 3 times 2 is 6. And even though you're saying, okay, we have 6 oxygens, that's not all the oxygens we have. We actually cannot forget the oxygen that is still another oxygen that is in the products. So there's not a number there as a subscript, so it's 1. So 4 times 1 is 4. And if I add those 2 together, it gives me a total of 10. So I've got 10 on the products and 2 on the reactants. Okay, so my question would be, how can I make this 2 into 10? So if I put a coefficient of 5, then this 5 would multiply by this 2 and make it 10. So now if I look through how many atoms I have of each, it's balanced. 3 carbons, 8 hydrogens, and 10 oxygens. So this would actually be a coefficient of 1. Okay, now knowing that we have that balanced equation, surprisingly enough, there it is. The balanced equation is on the next slide. It says there's a coefficient of 1, 5, 3, and 4, which is exactly what we came up with. You really need to have a correctly balanced equation, because if you don't, then this entire process will be done wrong for a mole-to-mole stoichiometry. But it's actually pretty easy. So let's go ahead and get started. First, start by reading the question. It says how many moles of propane, it's going to be important for us to really underline that because that's the first substance mentioned, are needed to produce 6.25 moles of water. Remember, the only number mentioned is always going to be our given. So the most important part that I want to point out is that you're currently working with the substance propane and the substance water. Okay, so water and propane are the only 2 things. In every question, you're going to have 2 substances that you're going to work with. Once you figure out what those 2 are, you go back to the balanced equation and go ahead and circle them, highlight them, whatever the case you're doing. So since I'm working propane water, okay, here's propane, and you're probably asking, why I didn't know that was propane. Actually, if you would have looked at when you first balanced it, it did say that propane reacts with oxygen. It's written exactly how you see it written. That sounds weird, but it is written in the same order, I should say. So that's propane, and then the other one mentioned is water. I want you to really pay attention at the fact that I didn't circle anything else because those two were the only ones mentioned in the question. So I've got propane and water. So that means I'm going to create what's called a ratio. Usually when you think of a ratio, you think of it maybe looking like this, like a 1:4 ratio or a 2:2 ratio or 1:2. Okay, well, we're not really going to set it up that way. We're going to set it up like a fraction. So this one, you see that there's nothing here? Well, we're on our ratios, we're actually going to put the word or the abbreviation for mole. So we're going to say that 1 mole of propane over, or for every 4 moles of water. And for the or part, all we have to do is flip it around. You're just going to flip 4 moles of H2O and over 1 mole of C3H8. And we do that so that we can have an option when we're starting to solve the problem. Okay, so our first task is, what are the steps? Step 1, given. Step 2, ratio. Okay, they're pretty easy steps for a mole to mole. So if I didn't say this, we are doing mole to mole stoichiometry problems. Okay, they're the easiest that we're going to do for stoichiometry. And then we'll progress to mole to mass, mass mole, mass mass. But this is the easier ones that we do. All right, so you start with your given, and your given is always placed in the first box, like we did with conversions. So 6.25, some of you are probably asking, where should you get that number? It's your given. It's the only number in the question. Moles, so you actually have to write the unit and the substance of water, H2O. Okay, just like we did the rest from before, know that nothing is ever written underneath the given, so it's just blank. And then the next step is a ratio. So this is where the or came in. You're going to pick option 1 or option 2. And it's not by guessing at it. It's actually pretty simple. Whatever the given unit is, that's the unit you want in the ratio step on the bottom, so they can cancel diagonally. So again, I want moles of H2O on the bottom because that's what shows up in my given. So does this one have moles of H2O? It sure does. Does this one have moles of H2O? Nope. So we're not using this option, and we stick to option 1. So therefore, all I'm going to do is copy it the way I see it, 1 mole of propane over 4 moles of water. Once I have that, because these match, they cancel diagonally, just like you see here. Let's see if I can show you a little bit better like that. Okay, so it canceled diagonally, which means that now all I have to do is the math that goes with it. So I'm going to take my values that are here. Let's see, let me use red to box them in. So here's my number value, and I'm going to multiply by the number that's next to it, which is 1. And then whatever answer I get, I divide it by the bottom number. So pretty much what I'm saying to do is 6.25 times 1 divided by 4. And that's going to give you the answer that's going to go there. Okay, once I calculate it, it is 1.5625, but I'm going to round to the nearest hundredth. And I cannot leave a number just like that. I actually have to put the unit. So notice how we had to cancel those moles of H2O because they matched. Well, we didn't cancel moles of propane. So we're going to put moles of C3H8. And if you look at the question, that's what they should be asking us. They should be asking us how many moles of propane. So let's take a look. Here it is. How many moles of propane? And that's exactly what we're answering. Okay, so that's how you do number 1 on this assignment. So let's, if you're still struggling, you want to see another one, you can go ahead and continue the video and watch what comes next so we can do the second question. If you feel confident that you want to try it on your own, then I would definitely stop the video or pause it and then do it on your own and check it with what's on the next slide. Okay, so let's go ahead and take a look. Okay, so on my next slide, again, I'm using the same equation you had to balance at the beginning. So let's take the steps a little bit faster this time. Okay, so taking a look, 3.23 moles of oxygen. Okay, so notice that this is my given because that's the number, and this is the substance that's being mentioned. Our reactant, how many moles of carbon dioxide? Okay, so now notice that carbon dioxide is also being mentioned, are produced. Okay, so now I take a look at my equation, my balanced equation. I'm going to find oxygen. It's right here. Again, it is in the order that it was written when you saw the first slide. If you're not sure which one's which, remember this one's propane, this one's oxygen, this one's carbon dioxide, this one's water. So on the question, we mentioned oxygen. There it is. That's why I'm circling it. The other one that was mentioned was carbon dioxide. So that's why I'm circling that one. Okay, now that I figured out what two things are mentioned in the question, I write them as a fraction, which is my ratios. So I'm going to put down 5 moles of oxygen over 3 moles of carbon dioxide. And then I flip it over and I put 3 moles of carbon dioxide over 5 moles of oxygen. Okay, so let's remember the steps. Step 1, write the given. Step 2, same thing, ratio. Okay, so my given is the only one that has a number. There it is. But I'm going to write the unit and the substance. So 3.23 moles, and it says of oxygen, so remember here's a symbol for it. So it's going to be 3.23 moles of O2. And now we pick the ratio. Don't forget that the ratio has to match. We really want it to match whatever we find on the given. So it should be moles of O2 on the bottom. So we know this one doesn't have moles of O2 for the first one. Okay, so the first one's not a good choice, but if you look at the second one, it does actually have moles of O2. So that's the one we want to use for sure, is the second option. Okay, so now I'm going to go ahead and write down that ratio, 3 moles of carbon dioxide, 5 moles of oxygen, which now matches, like I said, with the what I had in the given. So now I can go ahead and cancel these because they match. And all I've got to do now from this point is take my number values, which are my 3.23, multiply it by 3, and then divide it by 5. So you're looking at 3.23 times 3, that answer divided by 5. Okay, so since I know that you guys are experts at using the calculator, I'm just going to go ahead and let you use your calculator and calculate the rest of it. Don't forget, put your answer, but you also need your units and your substance as part of your answer. So don't forget to put that down just like we did it with the other one. Just to give you a hint, remember we didn't cancel this right here. All right, and the rest is yours.